Hello everyone, my name is Saurav Jha and today I am going to discuss about system design of LeetCode. So this task was given by Hitesh sir in a system design cohort. So let's start with the video. So as you can see my screen, so before designing a system, the first thing you need to lock in is our requirements, and you don't need to add too many features. You just need to add the important features needed for that V0 version. So for our V0 version, what are the requirements we are going to set is, let's write it down here, requirements. Requirements for a V0 version. The first thing we need is authentication. The second thing we need is the problem list. Then we need problem. Then we need the most important thing in LeetCode is the submission part. So that's the key thing there. And then we need a leaderboard. So the authentication part is very needed for our system to track the user. Then we need a problem list, the list of problem, and then we can also have some kind of pagination to optimize. And then we have a problem, a particular problem. While clicking any problem in the problem list, it will open a problem window there. And then we need a submission. So after writing the code, we need to submit the test cases along with the code and also the language in which the code has been written. And then we need a leaderboard to rank our users. So these are the basic requirements for a V0 version, but it's the important one. So let's start designing our system. So the first thing designing our system is we need a client. This client can be a mobile, can be a browser, doesn't matter, either of the two. So that can be our client. Then we need a server. Then we need some sort of a primary server. This is our primary server. Primary server means all our major read and write will be done here. And then we need a database. We are starting with the very high level. So the basic thing that is needed, we are designing that first the client, then a primary server, and then a database. So the database that I'm going to take is Postgres. You can take Mongo as well, but I'm more comfortable with Postgres, and my schema is pretty much fixed. I don't think I need anything extra filled in the future. So that's why I have selected Postgres, and the main reason being I'm very comfortable. You can choose Mongo as well. Both of them have their own benefits. So this is my database, but you need to define your system. You need to define your you can say the database. They may ask, the interviewer might ask questions regarding your choice, so you better prepare about them. So this is my client, this is my primary server, and this is my database. So what will happen now is the client can directly, should I directly allow my client to send the request to the primary server? So if there is one user, it's pretty good. If there is one user, you can simply take the client and send the request to the primary server, but it is not in our case. There might be more than, you can say, 100 users. So we need some kind of a load balancing to distribute traffic. So we'll have a load balancer here. Load balancer. Yeah. So it will help to distribute the traffic. It will work on a network layer. And then we need a API gateway. So this API gateway will be used for authorization checks, rate limiting. So this both are required for us. This and also API gateway will works on application layer. So load balancer is for distributing the traffic, and API layer is for checking, is also used to distribute traffic if there is a microservice architecture in future, and also it is used for authorization checks and rate limiting. So this layer is called an edge layer, that is between our client and the primary server, because we don't want to expose our primary server to our client. So that's why we have an edge layer here. Yes, so now let's discuss what kind of request client can send to a server. What kind of requests? So the first request can be, you can say, get problem list, because as soon as the client opens our coding platform, you will get the problem list. So get problem list will be the first request sent by the client. Then there can be get problem. After getting the problem list, user might select any problem and get to the problem page, and then after navigating to that problem page, the user might submit the code. So we need to post a submission. Post a submission. Post submission. Yeah. So this is the post submission part. So till now, what we have discussed, the request that can be sent by the client is get problem and post submission. So now what we do is, for the get request, it's very simple. We'll fetch it directly from our DB. We'll fetch it directly from our DB. No problems there. But while submitting any code problem, the first thing that we need to do is storing that submission regarded information to a database, because we don't need to execute in between, because there might be a loss of code, there might be some sort of a crash that leads to our submission data to get lost. So the first thing we need to store the data in the database, so that the data can't get lost. So that's why we are storing the data in the database. Now what happens is, after submitting this post request, the API, the server, will return us the response ID. That will not return us the code's execution result, because we will needing a separate server for that code execution to be performed. That will be discussed, that we will discuss later. But for now, what we need some kind of a communication between our client and the primary server to get the execution result. So for that we will be using polling. So that we'll discuss how this works. So what polling will, how polling will be done is, the client will ask the server whether my code is executed, and this will be back and forth communication till the execution result, till the client receives the execution result, whether succeed, fail, or timeout error. You might wonder why polling. We can also use server sent events. Yeah, that's a fair discussion, but for our system, polling is very good. Polling is very good choice for us, because server sent is preferably used for communication between server to server, and in our case the client is asking the server whether the code is executed or not, give me some sort of a response. So for client to server, polling is our good option. So that's why I am going with polling in our system. It may depend on other system, but for us, polling is our right choice. So that's why I am using polling. So this polling will be based on what? So this polling will be based on the submission ID that we will get after in the post submission. So this post submission will give some sort of a submission ID, you can say, or response ID, whatever you want to say, and based on this polling will start. So now comes the code execution part, where will the submission code would go and do the. So the first thing you might think is adding a server, like directly executing the code in the primary server. But the important thing to discuss here is the security part. What if the code is malicious? So if the code is untrusted and malicious, it will crash our primary server. So it's better to not run the code execution part on the primary servers. For that, we will need a separate server. So what we'll do is, we will need a separate server for this. Um, and this thing, and this is the code execution engine. This is our code execution engine where the code will be executed. We'll write it here, code execution engine, code execution engine. Yeah. So in this system, I will be using, so this execution engine will be AWS Fargate. So the execution engine that I am going to work with is AWS Fargate. Why AWS Fargate? Because I can have my own EC2 instances running on this server, but that will have some operational overheads. Like I have to manage the server, I have to manage all the infra that is needed. So what AWS Fargate provide is, it provides a compute engine. So with the help of this, I can run containers without having to manage that containers. So I can have, what I meant by that is, let's suppose I will have wait, I will change the color to white. Yeah. I will have my runtime environments here. Runtime environment here. So these four are separate containers that will be running. So what AWS provides us is, so AWS runs containers and manage the servers on their own. But what we need to do is, we need to allot the CPU and the memory. So we can limit the CPU and the memory also. And also we can, also AWS Fargate can auto scale the containers. If there is a lot of requests coming, there is a lot of code execution needs to be performed. So this containers is basically the runtime environment. So suppose in our LeetCode design, we have you can say we have Java runtime. We are basically having a runtime environment where the code will be executed. So we need some sort of a language based runtimes, so that the code will execute. The code will be run based on the test cases, and from where the test cases will be coming, this post submission, here we will get the problem statement, the user code, the language ID, and the test cases. So based on the language ID, this runtime will be selected, and based on the test cases, this runtime will execute that code. So here we'll have a JS runtime. Here we will have C++ runtime, and here we will have Python runtime. So also one of the key thing to discuss here is about the security. And what I meant by security is, let's write it down here. What I meant is, so what AWS Fargate provides us is, it is an isolated container. So there is no interference between any two containers. Isolated containers. Then one of the key security thing is, you can allot the CPU and memory part. and you can have timeouts. So what does timeout? It prevents infinite loops. It's gone outside of my window. It prevents out infinite. It will give timeout error. So CPU is done, timeouts is done, isolated containers is done. Also, if you want an extra security layer, what AWS Fargate provides is you can have an VPS abstraction to control the network layer as well. So network calls will also be handled. So this thing is also very important to discuss while like security is very important to discuss while you are running the code in the code execution engine. So AWS Fargate, that's why is very good, because it you doesn't need to think about the underlying infra. You can simply run the containers, and it is also useful for scaling as well. So yeah, that's why I have choose AWS Fargate in our LeetCode system design. Now comes the part where how will the task will be given to the code execution engine. So should I directly give through my primary server? So that will be an asynchronous job. So I don't think making it synchronous is a good option. We need some kind of an asynchronous way to handle our request so that it doesn't block our thread. So what we'll do is we'll need a queue system. So what I will use in this design is AWS SQS. You can choose other queue also, but I have used AWS SQS because I am very comfortable with it, and also it really does a good job in decoupling the, you can say, the primary server to the execution layer. So we need some kind of a decoupling layer. So that's why I have used the AWS SQS queue. And also one of the benefit of using AWS queue is like we don't have to really think about the long running processes. It handles really well. It handles the complex operations very well. And also it's a pull based approach that I am going to discuss now. Wait. So in this queue, what we are going to store? We are going to store the metadata, the submission ID, and you can say not submission ID, the submission related metadata. You can say the user code, the test cases, the language ID, because based on that the code execution engine will run our test cases. So from this queue we need a worker here that will delegate the task to the code execution engine. We need some sort of a task delegation manager. So this is a task delegation manager. It is worker. And what worker will do is worker will fetch the jobs from the queue. So it's a pull based approach. So in our design, the pull based approach is really good because the consumption should be controlled by the worker, not by the queue. So in push based approach, the queue will give the worker the task. So I don't think our system really requires that. Pull based is really good because there can be a very complex process. So worker needs to be the guy who needs to take the consumption route. Wherever they are ready, they will take the job and give it to the execution engine where it will perform the code in the available runtime. So this is the way how it will work. It will fetch the you can say the job, give it to the code execution engine. Code execution engine will perform the code, and it will give the result, and it will give the result directly to the server in sort of a API. They will create a sort of an API in which it will give whether it is successfully passed, it is failed, or if there is some kind of an error, there's some kind of a crash, there's some kind of a, you can say, a problem. It will give a timeout error because we are preventing the infinite loop here. So you can say the primary server will get the results based on our ID. the ID, the submission ID I'm talking about. So we'll get that and we'll simply store the result and give it to the client. So this is how it works. It is AWS SQS. Also, the fourth part that we discussed was the leaderboard. So how leaderboard will be created is, leaderboard will be a separate table where it will contain the user's information about the number of attempts, how many successful attempts were there, how optimized solution, optimized means the time taken by the problem to get submitted, and based on the time complexity also in LeetCode, as you can see, there is some sort of a ranking decided. So for that, we'll need a separate table, a system which will be a leaderboard. Yeah, this is some sort of a leaderboard that will be fetched. So now comes the point, like this get problem list, that get problem is also read by the database. Now the leaderboard, in this leaderboard of table also, all the reads will be done from the database. So so our database don't get overwhelmed by the read operation, what we can do, we can use the cache layer between them. So we can have a cache layer here. So leaderboard will fetch the data from the cache layer, and that simple mechanism is simply there, like if there is no data available in the Redis cache, it will directly fetch from the database and it will add to the Redis, and then the Redis provides the data. Also, we'll have some caching strategies for the invalid cache data. Yeah, we can do that. But for this system, what we have designed is, for the leaderboard, we'll simply take the data from the cache, so it doesn't overwhelm our database. And also this cache can be used by the get problem list and get problem also, because all in all, the problem list and the problems, they are also getted requested each second, like there is more request there. So yeah, we can use the cache layer that also, so that our database doesn't get overwhelmed. And yeah, so yeah, this was the whole system design for our LeetCode. I hope I have discussed every possible thing here. I may have missed some of the key points, as I'm also learning. So this is the first time I've created any video for explaining any system design, and I've quite enjoyed it. So I will continue to make videos now. So yeah, that's it from my side. Thank you for watching this video, and if you like this video, do give it a like, share, and write down your comments, write down any feedbacks you need. And if I've explained any topic, you can correct it that as well. Thank you.